Okay, the second thing I'm going to show you here is how to solve some problems here with angle of elevation and depression. And I'll give you a simple one here. Let's say this is a building, and from here, the angle of elevation, let's say, I'll make it an easy angle. This is 30 degrees. So that's 30 degrees. Let's say the height of the building is 100 meters. And let's suppose I want to know the distance from where I'm standing to the building, the horizontal distance. In other words, I want to know all of this, which I'm going to call x. Okay, to solve a problem like this, you're going to say, well, the tan of 30 is equal to 100 over x. The reason is because the opposite is 100 and the adjacent is x. So opposite over adjacent would give me this. Now to solve this, okay, you have to move some things around, and just be careful of it. Again, it's a two-step problem. I'm going to multiply both sides by x, which gives me 100 equals x times tan of 30, and then I'm going to divide by tan of 30, in which case I'm going to get x is equal to 100 divided by tan of 30. And I can just punch this in on my calculator. I'm going to come in here and say, well, that's 100. Okay, I'm going to say 100, sorry, divided by the tan of 30, in which case I get 173.2. So around, this is approximately equal to 173 meters. Okay, it's approximately equal to that. And so that's how far you would be away there. That's one way to do this problem. Okay, what you're gonna do here is it's gonna get a little more complicated here in a moment. And so the problems start looking like this. Okay, rather than something simple like this, what you're gonna get is you're gonna get questions where suddenly the person is standing up. Okay, and they have a certain height. I'm going to make him 2 meters tall. He's a tall man here. Okay, so they're going to be 2 meters tall, and there's a building right here. They're always in line with the building. We're going to assume it's always a flat ground here to make things simpler. And so suppose I had the exact same thing, and I said, well, this is 100 meters. Okay, same thing. And now I want to know x, this distance here. The problem changes here in that if we know the angle of elevation from his eyesight here, okay, if we know that now, let's say it's 30 degrees again. Okay, notice how the problem changes. Before we had this scenario, now we have this. Now this x, in fact, should be very similar to that answer. The problem is we don't actually know that it's 100 now, because remember, this height right here will be the same as this height, which is 2 meters. So in fact, this right here won't be 100. What will it be? Well, if this is 2, what's left over? 98. And to find this answer, I'm going to go 100 minus 2, and this has to be 98. So just like the last problem, almost identical, except now we're going to assume this is 98, because that's where the problem starts. Here's my x, what I'm looking for. I'm going to redraw this to make it a little nicer. And what it essentially looks like is this is 98, this is x, and this is 30 degrees. The trick to this one is that you had to subtract to get that. And now it turns very similar to last time. I'm going to say here that the tan of 30 is equal to 98 over x, or that x is equal to 98 over tan of 30. Okay, and it ends up changing the problem a little bit from last time. Notice last time I had to use the whole building. This time I can use this. The problems can become even more challenging when you have different perspectives. And it might look something like this. Here's a question. Here's a building. Okay, same idea. And suppose from here, okay, I know to the height of the building, okay, this is going to be 60 degrees. Suppose that I walk back, okay, I walk back 10 meters, okay, to this point. So I walk back. You can see that my angle here, okay, will get less. I'm going to make it 40 degrees. So at one point it's 60, now I walk back 10 meters, now it's 40. And this is 10 meters. Suppose I want to know this, okay, the height of the building. Now this is a challenging problem. And I'm going to show you how to do something like this. So this is 10 meters just to show you. That's 10 meters. And here's the height of the building. In order to solve a problem like this, okay, you have to go through a number of steps. Notice that there's this triangle right here, which I can't use because it's not a right triangle. And I need that to use trig. But I have this big triangle, which is a right triangle. And I have the smaller one here, which is also a right triangle. So I'm going to deal with this one here and just say that the tan of 60, that's the tan of this angle right here, is equal to h, opposite, over adjacent. Now I don't know what this is. I can call it anything. I'm going to call it, I'll call it x. So this length here is going to be x. Okay, so that's going to be h over x. I also know here that the tan of 40 degrees, this angle, is going to be equal to h, opposite, okay, opposite for this big triangle, over this whole adjacent side, which is 10 plus x. Now I want you to notice that obviously in these triangles that these two h's right here, I'll just put a little star beside it, these two h's have to be the same. They're both the same height. Similarly, these x's are the same. So I can start substituting and solving these. What I'm going to do is I'm going to multiply this across. And what I'm going to get here is I'm going to get, for h here, I'm going to get that h is equal to, well, if I multiply 10 plus x across times tan of 40, what I'll get is I'll get 10 tan of 40 times, or plus, pardon me, x times tan of 40. So it ends up being a little complicated. You're going to get 10 tan of 40 plus x tan of 40. Again, I just distributed this. Here, I'm going to get h is equal to x tan of 60. Okay, so just so you can see the difference. These h's, of course, are the same, in which case I can actually set this all equal to each other, and I'm going to get, if I take this side over here, I'm going to get x tan of 60 is equal to this, which is the same as h, which is equal to 10 tan of 40 plus x tan of 40. Now I have to rearrange everything so it's on the same side, and I'm going to move this variable that involves x over to the other side, and I'm going to get x tan of 60 minus x tan of 40. Okay, that's all going to equal 10 tan of 40, and now I'm going to take the x out, and I'm going to get x tan of 60 minus tan of 40 is equal to 10 tan of 40. I know this looks pretty ugly, but you're going to get a lot of math here happening. I'm going to continue this one here just below, and what you end up getting here is, if I keep rearranging this, I'm going to get that x is equal to 10 tan of 40 all over tan of 60 minus tan of 40. That is an ugly, ugly, ugly problem, but you can punch this all in your calculator now and find out what x is. The unfortunate thing is they weren't looking for x. What did they suppose? They wanted h, the height. Well, I can just plug it back into any equation here, maybe this one, and once I know x, I can say, well, then it's going to be that answer times tan of 60 to get h. And there are a number of ways to do that. So you might not be stopping here. You might continue on to solving for h, but again, you're just going to plug in your answer. But again, this could be an answer. You can punch this all in your calculator at once. Okay, don't round off in between, but it can be a little challenging to find these angles of depression and elevation.